Hello, and today I'm going to quickly explain some of the fundamentals of black holes. So first, the basics. What is a black hole? You might have heard that a black hole is like a vacuum cleaner, and in some ways this is true. A black hole does suck up some of the nearby stuff, but it's not nearly as clean as a vacuum cleaner. If you imagine a vacuum cleaner vomiting basically half of the stuff that it takes in, then that's a bit closer to a black hole. Also, vacuum cleaners are powered by a vacuum. Wow! And black holes are powered by gravity. So I'm gonna quickly draw a diagram of a black hole and some of the surrounding areas. So you have the black hole itself, so this is the black hole, and then around it you would have like a disk. So that's the disk. So like a disk like this, and then this is shining very brightly. So yeah, it's shining quite brightly. Then you might also have like a beam of light coming from the black hole, maybe straight towards us in this case. So you have the disk, and that's kind of like the vomit of the vacuum cleaner. So yeah, black holes, and they're really tiny here. So if this was the disk size, then you probably wouldn't, well, you might be able to see the black hole if you could see black holes, but it would be really tiny. So also, and they're formed by star collapse. So when a heavy star that weighs more than 3 times the sun collapses, if you imagine the star is here, and you have the core of the star, yeah, then it's collapsing, right, from all sides, and it can collapse very fast at like a quarter of the speed of light, I'm pretty sure, is the maximum speed it can collapse. It kind of rebounds off of the solid iron core. So basically, if you imagine the star consuming its fuel, and then you have, if it's a car, then the thing is, the star is very smart. So it takes the exhaust and eventually takes that as new fuel and keeps going until it gets to iron. It can't use this as fuel, so the energy that keeps the star from collapsing is gone. So the star collapses, bounces off like into a giant supernova, and well, basically this is what the supernova may look like. Imagine this is not a disk but an envelope of gas, which is these outer layers, and then the core collapses under gravity, and if it's heavy enough, then it will collapse into a black hole. And so black holes, basically the official definition is it's so dense that light cannot escape. So say you have a black hole here, then a beam of light coming from here, let's say, it's going towards the black hole, beep, 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 beep. It hits the black hole, but the horizon of the black hole, it's gone forever, basically. And the gravity is also so strong that light can bend. If you have a beam of light, then it could bend like that because of the gravity of the black hole alone. So what would happen if you fell in? I bet you're wondering this. So if you fell in, then what would first happen is called spaghettification. So basically, spaghettification means that you are turned almost into a piece of spaghetti. So you would be like pulled from one end. So first, if you have a little human here, yeah, so that's you. Because you're sad because you're about to die. So basically, if you can imagine, so first you would be pulled like that, and first it wouldn't be very strong, but as you got closer to the black hole, it would be stronger and stronger. And then right after that, so it's sort of like a push-pull, push-pull. So after this happened, then you would be pulled from this side, like that. So you would be stretched like that, and then stretched like, and then stretched like that, then stretched like that. Then this will get faster and faster until every individual atom of your body, so here's an atom, let's say this atom's name is Bob, it'll eventually be alone, all on its own. So if you have the atoms, eventually they'll all be pulled apart. Then what happens inside the black hole? So this is still like a little bit theoretical what I'm saying right now, because we don't know what happens inside a black hole. If I was to just go on a nice morning stroll and go into a black hole, I could not transmit the information back out. This actually causes a very complex paradox that I'm not going to explain right here, but it's sort of like information can't be destroyed, and then here information's being destroyed. How does that work? So that's how the paradox basically works. So really imagine I'm inside the black hole. I can't just like, if I keep an arm outside of the black hole somehow with like a light speed spaceship or something, then aside from the fact that the rest of me would just get pulled in and the arm would get like pulled out and spaghettification, aside from all that, I couldn't send an electric signal, right, like through my arm to get my finger to move and say send a message like hello, like imagine typing on a keyboard. I couldn't do that because nothing can go faster than light, and you need to go faster than light to get out of a black hole. So what's in the center of a black hole then? Basically, so the black hole itself isn't really an object. It's more like you have the center, which is called the singularity. It basically has, at least what we think it has, is infinite density. So there's like some amount of matter, presumably the mass of the star's core, squashed into a space, into an area that takes up no space. Can't normally happen. When it happens, it creates a black hole. Okay? So basically, the hole itself, like, you know, the horizon around it, the event horizon, is where the gravity, the boundary, where the gravity is so strong that nothing can escape. Another weird effect that's caused by relativity that would happen if you fell in is that it would look like if anyone was looking from outside, if you imagine that the black hole is here, it would look like you fell in. Like, imagine I'm going at like half of light speed because I'm falling in so fast. And then it would look like I slow down as I get closer. And when I hit it, I stop and stay there forever, basically. That's what you would see. But what I would feel is just going and going. At least that's what we think. Then there's some theories that there's a firewall, like a computer firewall that prevents like some evil program from getting in the computer. This prevents any like thing getting in. So some kind of, the simplest version is fire. That's why it's called a firewall. But it could be really anything else. So now I'm gonna explain one of the most complex things about black holes: Hawking radiation. So if you have a black hole, say this is the black hole, okay? And then you know that the gravity is super strong, right? So you would feel the gravity outside the black hole. You feel the gravity of the Earth even though you're not inside the Earth. You're on top or above it. So you still feel the gravity of it. Say here. Okay? You would feel it all through here, which means that it has a gravitational field. And because E is equal to mc squared, which means that if you have enough energy, you can turn it into mass. So if I had enough energy, I could turn it into a weight and use it like to get buff. Anyways, yeah. So you have so much energy in there that what happens is that particles, they pop up seemingly out of nowhere. So this can happen normally. Imagine they're borrowing energy from the universe and giving it back. But the particles only live for like very, very, very small amounts of time. But here, because there's so much energy, there's two particles. One of them, so say you have the two particles, see, remember that's the black hole. So we have particle 1 and particle 2, which is the anti-matter particle of particle 1. So the anti-particle 1. Then if you have these two particles, what happens most of the time is that one of the particles, doesn't matter which one, falls into the black hole. Remember, these are all created by the black hole's energy, and one of them flies away into the universe. So this particle is being taken from the black hole, which means that the black hole's mass goes down. And in like trillions of trillions of trillions of trillions of trillions of ... years, then eventually any black hole would evaporate, basically, and turn into nothing. Now I'm gonna present to you an idea that can happen. So if you take all these, say I fell into a black hole, and someone collects every single one of these particles that comes out, then eventually they might be able to reconstruct me, and I would be back to record more awesome quantum videos. But could this happen in reality? We don't know. One of the many mysteries there are. And so, this quick explainer is over. And remember, you're never too young to explore.